So that is quite important, and that way you can access material that you may have missed yourselves or some colleagues. I also would like to remind you that there is an event app for the Drone Enable 3 Symposium. If you haven't done so, you can connect to the ICAO public Wi-Fi and download the app from the Apple App Store or Google Play Store, searching for events at ICAO. We would like to encourage you to use the app, and also while doing that, in order to ensure the seamless flow of presentations, we will also ask you to kindly place your smartphones, electronic devices in aircraft mode, or at least silence. Another practical announcement, please refrain from bringing any food or beverages inside this room to protect the audio equipment that is on the tables. I don't know about you, and I'm pretty sure you share the same feeling, but I thoroughly enjoyed yesterday's insightful exchanges and sessions. So today and right now, I would like to keep the momentum going and focus on this year's RFI problem statements. Now, before we get into the sessions themselves, I would like to introduce this morning's keynote speaker, Mr. Florian Guillermet. Mr. Florian Guillermet was appointed as Executive Director of Single European Sky ATM Research Joint Undertaking, CESAR-JU, in April 2014. Florian is responsible for leading the CESAR-JU public-private partnership, which is modernizing Europe's air traffic management system. Florian has worked in the civil aviation field for 20 years. He is an engineer and graduate of the École Polytechnique and Civil Aviation Engineering School in France. He holds a master's degree in aeronautics and airport management. Ladies and gentlemen, please join me in welcoming Mr. Guillermet to the podium.
Morning, everyone. Thank you, Frédéric. It's really a pleasure and an honor to be here. It's always good as well for me because it allows to take stock a bit of how we progress as a community on the development of the drone air traffic management system, or whichever way we call it, UTM, U-Space, as we call it in Europe. I think it's essential that once in a while we meet here in this House of Aviation to discuss the progress, and this is what I will try to highlight in a few slides this morning to you, but that as well that we acknowledge what has been achieved and what remains to be achieved. And I will talk about as well where we stand in terms of this progress, but as well what remains to be done and where we perceive, at least from the work that we've been conducting on U-Space and on the drone traffic management, what remains the key challenges to be addressed by the community at large. What do I have to press? That's the only question. Do you have the clicker? There's a red button here. I always a bit encouraged to press red buttons. Okay, so let's get back to why we are here. I mean, this slide, if you look at the numbers, are really not aiming at being accurate. It's just a kind of high-level description of how we perceive the new traffic developing in our airspace. There is, largely speaking, a growing appetite for a number of companies, from a number of services to be delivered through the airspace. We see that at low altitude, and this is definitely where we do see today most of the drones operations. We see that as well in higher altitude, where basically so far we didn't have so much traffic. There is a growing as well increase or demand to access this airspace. And somehow the traditional aviation system is a bit in the middle. It's a kind of a sandwich if we look at the airspace in that way. And I think what is interesting in this slide is that immediately what the number says, again, they're not aiming at being accurate. They say that we have a need to build a new system, that the current system of air traffic management, as we have designed it over the years, cannot cope with the diversity, but as well with the number of flying objects that we will have in the lower airspace, and most probably with the complexity of as well having upper airspace operations all together within the same airspace. So this is why we started this journey on the so-called USpace about 2 years and a half ago now. This was beginning of 2017 in the case of Europe, a little bit earlier in the case of the US, in other places of the world. Pretty much things started in the same way at the same time. I'm not going to cover in detail the notion of USpace. It's very similar to the one of UTM. We do not pretend we are inventing a completely new thing from that standpoint. Maybe one thing to highlight is that USpace is not an airspace, contrary to the name. The notion of USpace is really focused on services that have to be delivered for the secure operations of drones. So it's definitely a concept, a notion which is service-oriented. Another key element or key attribute of the USpace, and I will come back on that in my conclusion, is that it's based on standards. We want the system to develop on standards, and on standards which are not technology dependent, which are mainly performance-based standards. We want as well, and that's a key attribute of the USpace, to be highly automated for a good reason, which is that we need scalability. We need progressively to be able to deal with a certain number of drones, and progressively to scale up these services across the European airspace, across a variety of airspace, and across a variety of operations. I think one of the key elements as well is that this USpace has to provide key attributes in terms of security, in terms of safety, and this is as well captured in the concept of operation, in the notion of USpace at large. What is interesting to highlight as well is that USpace is not something which is carved in stone, that we are going to define and that will remain like that forever. We are at the early days of the definition of the USpace, of the validation of the USpace, of the implementation of the USpace. The way USpace was designed is to evolve as well according to two key elements. The first one is related to the vehicle, the fact that we will have more and more automated vehicle flying in the airspace, and that the degree of autonomy, the degree of automation will progressively increase, and so will the USpace services that will enable those operations. The key other element is the degree of connectivity of the drones themselves, or the vehicles themselves, between them and the infrastructure, and between themselves with one another. It's really important as well to understand that the services that will be provided by the USpace or UTM Service Providers will have to evolve according to these notions in time. We've put a kind of time frame there. and definitely the focus today is on the level 1 and level 2 of the U-Space services. But we are as well exploring in the work that we perform the different levels which bring in, again, more automation, more autonomy to the vehicles, and as well more connectivity to the system. This blueprint of the U-Space was defined about 2 years ago, in 2017. I will say that as a blueprint, it remains quite valid. I think the key notions, the key principles that I've just highlighted are remaining pretty much the same. Where you will see we have some evolution is definitely in the concept of operations, and there are some areas which are definitely challenging as part of the development of this concept of operations. What I want to show today are a couple of results of our portfolio of activities. We've been able in Europe to develop that in less than 2 years with some public funding, but as well with a lot of investment from private partners, from private stakeholders in those projects. We cover a wide range, I will say, of stakeholders who are engaged, as well as you will see a wide range of use cases and potential services to be delivered from the drones themselves. What I want to highlight is that this remains, however, a limited portfolio. So we do not pretend we cover everything, and that's why it's essential as well that we team up with other regions in the world under the ICAO umbrella to exchange information, to exchange experience on what has been done, what remains to be done, and that progressively we develop together this new system. What I want to highlight as well is my apologies, because I will mention a number of projects. I can't mention all of them. Some of you who are sitting in this room probably participate to some projects that I won't be able to mention today. So we've just made a kind of selection just to illustrate what we do, but as well what kind of challenges we face in doing it. I'm not expecting for you to read all this. It's just basically a presentation of the portfolio of activities that we conduct under CESAR, which shows the type of, I would say, services, and they are described there in green, or type of activities like the work on the concept of operation, on the architecture, or on some key elements or key attributes like security and cyber resilience that we are working on in the project. And in blue, basically, you have on the right part of this slide the type of services that are being addressed. And for me, this is really essential that we look at the use cases, because there are these use cases are what is important at this point in time to understand what kind of requirements we need to have on the system. So you will see that there is a very wide range of services, use cases that we are testing in those projects. Some of those projects are of demonstration nature, so it means that they are pretty high in terms of technology readiness level. Some of them, they are very close as well to being able to be operationalized. And some other activities that we conduct are more looking at, I would say, more advanced services and more in the domain of exploratory research. But altogether, I will say they allow us to cover both a wide range of use space services and a wide range of use cases, and as well a combination of the two, which means that we look at how we can combine within one airspace different use cases for different purposes. That's the case, just to mention one of them, like the Sapphire project, where in the harbor of Antwerp we conduct commercial application, parcel deliveries, monitoring of the harbor for surveillance purposes, as well as medical services of high added value. All this combined within the same airspace and tested in the same airspace. The last thing I wanted to highlight on this slide, it's, in my view, not the end of it. That's really the beginning. Those demonstrators, those activities, they allow us, again, to secure some of the elements that we believe are mature in the use space, but as well to identify the challenges and the difficulties that we see growing as well when we progressively scale up operations, when we make them more complex, when we make them more interoperable, including with the traditional air traffic management. Well, this provides you with a view of the geographical landscape that we are addressing as part of these projects. We are not covering the entire European airspace, but we have quite a number of countries, member states, as well as local communities that are really involved in those projects. What I want to highlight is the fact that every time we really build those projects as sandboxes, which means that not only we bring drones operators, we try as well to bring traditional ATM players. We try as well to bring all the time authorities, whether they are local authorities, like in the case I was mentioning, the Harbor Authority of Antwerp, or national authorities, or European authorities like EASA, to try to understand what can be the requirements in terms of making sure that we progress as well the regulatory framework together with the development of those services, and that basically we are not going too fast in terms of regulation, which will potentially block some of the future services, or that regulation is not too late compared to the pace of technology and the pace of development of those operations. So I've picked there a couple of examples. The first one, don't ask me about the name of the project. Our project teams, they always have a good imagination to invent names. This project is called Podium. The particularity of this project is really to work on some element of the concept of operation in different geographical areas, and as well to look at different use cases. What I think is interesting is the fact as well that some of those activities, they are looking at the interface with air traffic management, which is a key component of how use space is developing. So what type of services, what type of component do we need to address to make sure that there is a smooth interfaces between the use space, UTM operations, and air traffic management, in particular in the vicinity of airports. I think one key element is as well the interoperability with manned aviation. So there we look as well how in the same airspace we can have a combination of drones operation and manned aviation, whether it's I would say I mean all type of manned aviation, light aircraft as well as helicopters, for instance, and gliders. I move to another one. This one is really focusing on the, I would say, more short-term delivery of the services. So it's the early services which are defined in the scope of U1 and U2, like the identifications, the registration, the surveillance tracking, and as well how do we manage dynamically the airspace so that we can protect certain areas, so that we can as well overfly certain areas. Including in all types of dense and less dense populated areas. So this activity look at, I would say, a more early implementation or early possibility of implementation of use-based services. This one is another specific one. It's really focusing on what is called the geofencing capability, so the ability to protect a certain part of the airspace, whether it is from a strategic standpoint, like protecting typically a nuclear plant, an airport, and so on, or whether it is purely tactical, like there is an accident and we need to protect basically the airspace above this accident, or any kind of other much more tactical way of handling the airspace. We have as well there a lot of elements which are interesting in terms of performance requirements related to the geofencing capability. And maybe that's one already element that I want to highlight as not a conclusion, but I will say early findings of those demonstrators. The fact that the performance requirements, both for the vehicles and for the systems, are extremely important. And what we do see, that it's not, we can't take it for granted. We do see a number of difficulties for some drones, for instance, to navigate properly, to keep the level of accuracy which is required in order to do proper geofencing, for instance. Another example here is the so-called Vutura project. It's pretty much the same, by the way, in the Sapphire project. The idea there is to test the possibility to have multiple use-space service providers within the same airspace, including for the ability to provide separation management. And this is an interesting case because we've encouraged our projects to work along those lines to assess the difficulty of going in this direction, because that's something obviously which is unusual in the traditional world of ATM. What we see today is that it is something which is feasible. We have no indications that it's not feasible, but there's still work to do in order to allow this to happen. We have other projects which are taking different pace or different, I will say, paths. Some of the projects, for instance, are more looking at one airspace allocated to one service provider, so more in the traditional ways that we handle traffic in air traffic management. Finally, this is the last slide I wanted to provide as an example. This is related to urban air mobility, and not only, we test as well a number of other type of application, but this is one project where we do have an application related to urban air mobility. This vehicle is a volocopter vehicle, which is an electric one, which is going in the process of certification, and actually it flew for the test of this project in the Helsinki airport area to test as well how we can insert such traffic with highly autonomous vehicles into terminal maneuver areas, into airports, into the management of the traffic at an airport. So this project is as well interesting from that standpoint. It's as well interesting because it's looking at a different architecture component, like the flight information management system, which, as we know, is a key element of the structuring of the use-space services. So where do we stand in terms of our timeline? The idea of all these projects that you've seen is progressively to come to fruition between, I will say, mid of this year and end of the year. So we are right at the end of most of the validation campaigns that those projects have been conducting. There are still a few that are remaining towards the year end. But basically, on the basis of these activities, we are starting to gather all the information related to what we see in those projects, to what as well remains to be done in terms of research and development and validation activities. Of course, some of these projects, they are demonstrators, some others, they are more, I will say, pure research and development activities, but nevertheless, we're trying to progress on some conclusions, on some, I will say, find outs that we have already established. The first one that I mentioned already is, just to give you a flavor of how we perceive things at this point, is the level of performance. What we do see is that there is still a lot of work to be done in terms of making sure that the vehicles as well as the use-space services reach the required level of performance to ensure the safety of operations. We, of course, in most of the cases, use development platforms, prototypes. Nevertheless, we do see that, for instance, the capability to communicate, the capability to navigate in some areas is not to the level where we expected it to be, or where I would say the industry was claiming it will be. So that's already an important finding, that basically the requirements that we know very well in aviation for the CNS system, we do see difficulties at this point in time to have that met in the context of use space, especially when we look at urban areas where we definitely have significant issues in terms of loss of communication or in terms of pure positioning of the vehicle. The second element to highlight is related to the standards. So we have tested, as you've seen, a wide variety of stakeholders, of use cases, and so on. It is very clear that if we don't reach quickly a level of standardization of those different services, a level of standardization of the different approaches, this will never work. We will face an issue in terms of a patchwork of stakeholders that will try to do their own thing, which will never reach a critical mass to allow the use space to develop as we foresee it to develop in the future, and therefore to allow the scalability that we want to have in the system. And I think this is really a key element. We do see a lot of good things in all those projects. We do have concerns in relation to the ability to scale up those operations, whether it is in the same airspace or in different, with more drones, or in different airspaces across Europe. Therefore, it is very critical that we look at the standardization activities as a key element, that we put the right priority, that we put the right as well resources on those activities to end up with a system that can be interoperable and scalable. Finally, the last element I wanted to highlight out of the work, again, that we will try to consolidate beginning of next year to have, I will say, a state of play of use space after those 2 years of project activities. The last element is related to the concept of operations. This work is very essential. It's quite complex. We do see difficulties, for instance, to stabilize the concept of operation related to separation management. We are a variety of proposals in relation to how to separate the traffic between drones, but as well potentially between other airspace users. And for the time being, I don't think we have a kind of silver bullet where we can say, okay, this is the way forward, there's no more discussion. We still have work to do on this concept of operation. In my view, this is as well pretty much the same on the architecture aspects, where we do see, again, a number of elements that are stabilizing, but this is not yet the end of it. So in a nutshell, what will be the conclusion, I would say, out of this 2 years period is that, yes, we have significant achievement. We start to have services which can be rolled out because they have reached the level of maturity, but there is still a way to go, and research and development as well as demonstration activities to be conducted. And beyond that, at some point, we have as well to think how concrete services, vehicles as well will be certified for some of the operations that will be conducted over densely populated areas, for instance. Last thing I wanted to highlight is on this slide, and that's really why the use space somehow is not an airspace. So it's a bit complicated, but I will tell you briefly what it is. We cannot take use space in isolation from the rest of the air traffic management system, from the rest of the airspace. Otherwise, we will simply end up with another type of segregation. So we've conducted some work recently in that domain to see how the architecture of the airspace itself can evolve as well, to take progressively into account the growth of the use space. This relies, of course, on data services. This relies on progressively, I would say, if not emerging, progressively a good complementarity between the use space type of services and the traditional ATM ones. And I think this is work that is essential in the future to make sure that we have a system where we will reach some degree of convergence. I'm not saying it's for next year or for even 2025, but when we look at the 2030 time horizon, we do need to have a degree of convergence between those different approaches. A key element to help us going in this direction is on the right part of this slide, is the work that needs to be conducted on, I will say, the automation, autonomy part. We need to have a roadmap for that. We have established them in the context of the new European ATM Master Plan, and we are about to issue a new edition which is fully aligned with the Global Air Navigation Plan. There is substantial work to be done in this area because we have a system today which is highly manual. It remains highly manual, which is poorly connected if we look at the traditional aviation environment. And these are the two axes in which we need to speed up things if we want to reach this degree of convergence at some point in time. So this concludes my presentation. Thanks again for listening. And I know there might be questions coming up later on at some stage. I will remain in the room in any case for the rest of the event. Thank you very much.
Thank you very much, Florian, for setting the stage for today's discussion. As a reminder, and as we move into the RFI session, we'd encourage you to start thinking about questions you may want to ask while listening to our speakers. You are also encouraged to submit these questions to our dedicated mailbox, plenary_1 at ICAO.int, plenary_1 at ICAO.int. Please also remember that the information gathered from these sessions will be used to develop edition 3 of the UTM framework. So we'd like you to think really of this exercise as an opportunity to shape up the discussion around where UTM is going and how to get there. So we strongly encourage your participation. Now I would like to introduce this morning's Stream A session, which will address the issue of UTM Service Provider organizational construct and approval processes. This session will be held in 2 parts, separated by our morning coffee break, and will be moderated by Mr. Carlos Cirillo from IATA. Mr. Cirillo is a senior aviation professional with over 25 years of international management and operations experience in civil and military roles. He served as the Brazilian delegate to the ICAO Air Navigation Commission. Mr. Cirillo holds the rank of colonel in the Brazilian Air Force with more than 4,500 flight hours in military and flight inspection aircraft. He's currently the IATA ATM Infrastructure Director, responsible for IATA global policies and positions related to communications, navigation, and surveillance, as well as air traffic management infrastructure. Please, ladies and gentlemen, join me in welcoming Carlos and his panel to the stage.
Thank you. So can I invite my first 3 speakers? 4. So good morning, everybody, and thanks for joining us today on this very long, the name of the session is impressive, UTM Service Suppliers Organizational Construct and Approval Process Session. Florian, thanks for your presentation. You helped me because I don't need to go to the introduction. You did the introduction for myself. So Florian very clearly specifies some issues that we have to address. I was supposed to go and read the problem statement for that we apply the RFIs, but he clearly specified where we are trying to address. Specifically, with our session, we address some issues and concerns. For example, what are the potential certification requirements for UTM service providers? Whether they should be held to similar standards as we have today for the ATM service providers. What standards would need to be applied if certifying our USS, and what organizations would develop such standards? So it's a very broad area. You'll see during the presentations that they cover different aspects of the same solution, so please pay attention to the different presentations, and your questions will be more important than anything else for us to come to a conclusion. So as said, our stream is going to be in 2 sessions, one before and one after the coffee break. We'll try as much as possible to address solution in the first break. But if you run out of time, we are going to do all the question and answer after the second session. So without further ado, let me welcome to the floor our first speakers, and bear with me, we agree that we are not going to introduce everyone all the CVs. They're very long as my CV, apologize for that. But you have there on the app. So for this first session, we have Ms. Cristiano Baldoni, Head of UTM Engineering, and Ms. Fabricio Durso, Airworthiness Regulation Department for NAC. Please, the floor is yours.
Good morning to everybody. Thank you, Carlos. First of all, I wish to thank ICAO for the opportunity given to Italy through ENAC, Italian Civil Aviation Authority, and ENAV, the Italian Air Navigation Service Provider, to present our approach on U-Space. The present scenario is represented by an exponential growth in the use of drones for commercial and recreational purpose. These offer big opportunities, commercial economical opportunity, but also significant challenges. From our point of view, the biggest challenges is to allow drones to fly safely in a unique and always busier sky. This will be possible thanks to the implementation of a certain number of services, let's say the implementation of U-Space. Italy, through the cooperation among 3 institutional bodies like ENAC, ENAV, and Italian Air Force, has already started the implementation of U-Space services. And this will be, Cristiano will talk about later about it. What is the, where is it? Oh. Which one? This one? Okay. During the first drone enable held in 2017, ENAC and ENAV announced the signature of an agreement mainly focused on giving compliance to some requirements of national regulation. And this agreement was contained mainly three main subjects. The first one is to develop a web system for registration and identification. This is the first step of U-Space services. According to this agreement, ENAC retains a responsibility for as a civil aviation authority for registration and identification, and ENAV is indicated as the unique provider for these services. The second aspect is outside the scope of this presentation, but it was the identification of a set of rules in order to establish a regulatory framework for VV loss operation in Italy. And the third one was the most ambitious. ENAV committed to develop an infrastructure in order to deploy U-Space services in Italy. What is important to note is that this agreement was signed by two institutional bodies. Doesn't matter the fact ENAC is the Italian Civil Aviation Authority appointed by the member state. It is in charge, of course, for regulation, certification, oversight, and so on. And ENAV, according to ICAO and S11, is the unique air navigation service provider in Italy, appointed by the Italian state for providing navigation services for airspace and airport under its competence. That means excluding the military ones. So, having been this signature, this agreement, having been signed by two institutional bodies, it is coherent with the national and international aeronautical scenario. As I told in my previous slide, one point of the agreement is the development of an infrastructure for the deployment of U-Space services in Italy. This was done, ENAV, along with some industrial partner, Italian industrial partner, developed this infrastructure named D-Flight, and for providing for the deployment of the U-Space services, also to be compliant with the new European regulation framework. It doesn't matter the fact the flight is able to provide e-registration, identification, geo-awareness, displaying maps and no-flight zone. All these four are important because are services already also requested by the new regulation 947. In addition, the flight is also able to provide additional non-mandatory services like support to mission, support to the pilot, and so on. Before concluding my presentation and leaving the word to Cristiano, I would like to say that the Italian approach on U-Space is based on the convincement that the role of the U-Space service manager should be played by the National Air Navigation System service provider. Why this? Because for us is our convincement that it's important that we can rely on already well-structured entities, rely on this organization that they have a good expertise and a good organization in terms of personnel, in terms of procedure. And today, the whole organization that can have this requirement are the already appointed air navigation service provider. This is all for me, and I leave the word to Cristiano.
Thank you, Fabrizio.
Good morning, ladies and gentlemen. Thank you again to ICAO, to the panelists, to the chairman of the panel, to Florian for introducing his keynote this morning, and of course to Fabrizio for introducing the rest of the presentation, which regard the Italian approach to use space. So I'll try to be as fast as possible. If I manage to click the right button. All right. Okay, I have to go a little bit one slide earlier. So what is about the flight? As mentioned from Fabrizio, in Italy, the Air Navigation Service Provider, together with the Civil Aviation Authority, decided that there was a need for an action with regard to drones to accommodate them in a safe manner, and the best solution was to let the action to the NSP, especially with regard to the development and deployment of the right infrastructure. We started quite early. I would say that in 2016, the term use space was not yet there. At that time, we were using the worldwide naming, which is Unmanned Aerial Vehicle Traffic Management, or UTM. Later in Europe, we decided to name this in an original way, which is now known as use space. So what actually ENAV did? And a first step, aside the signature of the agreement between ENAC and ENAV, we started to develop an experimental portal for services, as mentioned by Fabrizio, especially for registration and electronic identification, in an initiative which was named internally DFlight. But soon we set up a proper company. So DFlight SPA is actually a daughter company from ENAV, and what we realize also is that inside ENAV, so inside the daughter company DFlight, we wouldn't have the right competences to exploit and to deploy what was needed for UTM/use space. So we immediately started a procedure for seeking for an industrial partner. And we did this through an open tender process, a public tendering process, European-wide, which lasted it required quite a significant amount of time. It occurred almost 3 years to complete this procedure, but finally we found the industrial partner, being Leonardo and Telespazio. So the tender was awarded by two main industrial Italian players of the dimension of Leonardo and Telespazio, with very great competences to support the development of the use space in Italy. So basically, the industrial partner has a double role within the flight. It's both the partner, the industrial partner, let me say the capital venture, the venture capitalist of the flight, but is also the main supplier for the platform. Services are already available. You can find them at www.dflight.it. In particular, it's already online the service for geo awareness, so that everyone, recreational users or professional users, based on the quite complex rules for flying, and we saw, I think, very interesting presentation yesterday about how what is the level of complexity for flying drones in our use space. The users can go and in a click verify whether in a single volume of airspace they can fly, they cannot fly, or on what basis and what kind of authorization they are authorized to fly there. Some more advanced services were already validated into a demonstration project funded by Cesargio Undertaking. The name of the project is Diet, and we completed the demonstration activities in September this year by proving a number of BVLOS flights under the same portion of controlled airspace in a city of Italy. So basically, the flight is deploying a roadmap exactly following the blueprint roadmap which was presented by Florian earlier this morning, but with some level of anticipation. Our ambition is to deploy up to U4 services already by 2025, considering our objective, which is enabling autonomous flight. Of course, this is the final target, passing probably through the exploitation of BVLOS operations, which we consider are the key aspect, the key way to use drones to serve, in particular, enterprises for inspection management, for an example. That would probably be the first area of business for the enterprise to use drones within their industrial processes. We have a notion architecture, or a high-level target architecture, which is kind of the flight signature. I'm quite proud of this schema, because despite this schema was designed, I would say, by myself in 2015 now, 4 years ago, more than 4 years ago, the high-level notional concept is quite yet valid. It really provides, in a centralized fashion, all the services that are expected by the USpace, a USpace solution, and are included in the USpace service portfolio. One important key element of our high-level architecture is what we call the UTM box, and I saw early this morning Unifly having a UTM box, so I think that our idea in 2015-2016 is still quite valid. What changed really is that at the very beginning we included in our business plan the manufacturing of the UTM box by our own. We realized that also considering the level of development, the level of maturity of the regulation of the current and the current state of regulation and standardization, it would be of tremendous impact in mobilizing a significant amount of capitals by a make choice for the UTM box. So we are now reconsidering this choice in our business plan, and we are seeking for the developing standards, of course, in harmonization with what is emerging currently in Europe and in the States with regard to, in particular, remote electronic identification in both local and network. But our concept remains still valid. We are completely convinced that a NUCON device or capabilities development directly within the drone as it is produced by the producer should have on board to make itself identifiable remotely and sharing in a cooperative way its identity and its position with the USpace service providers. I add the S at the end, in order to be sure that their position, every drone flying, it's known, and every flight intent is known, so that the USpace can really maintain a complete and real-time situation awareness of the entire airspace interested by drone operations. You can see some of the technical solution and the front end of the flight, which was used in the experimentation in the diode context. You can see at our booth, you can have real-time and live demos on what we already developed in terms of prototyping of the services. We have a tracking system. We have the advanced label representing all data about drones flying. We have the monitoring of the area, so the geocaching, the flight intent, warning systems broadcasted to all users, and so on and so forth. So I think this is quite interesting, and you can see at the coffee break outside here. A very interesting thing, which I didn't really hear in the presentation yesterday, is the role of Air Force and other institutions within USpace. I think this maybe is something that has been so far underestimated, or maybe due to the peculiarity of each own state, this could change state by state, of course. For instance, in Italy, the military Air Force is playing a very important role. The the Italian Air Force is both responsible for the defense of the airspace, but is also at the same time a recognized air navigation service provider for the whole military airspace, and is also one of the main airspace users of those portion of airspace. So how can we let an Air Force, at least in the context of Italy, outside the development and the deployment of any U-Space solution? We can't. So we need to keep them in the loop. But also other elements that concur to development of the U-Space for which we need to take into account are other police forces, ambulances, emergency flights, state flights, all those kind of flights that are in particular interesting very low-level operations, and are those that would probably be impacted the most by an intense use of this small portion of airspace from these new kind of uses such as drones. So we need to keep them into account. We need to keep all these kind of different institutions, which might not be only aeronautical, in any authoritative process. And I like pretty much the presentation I saw yesterday in the last session, which were actually touching this very complicated point. We might have national parks, we might have Ministry of Cultural Heritage, we might have the cities, which could somehow be interested in a collaborative decision process for authorizing a drone flying over a certain portion of airspace. And this just for VLOS operation. Even when we're considering open category operation, which in the EASA mind do not require any authorization, I would say this is not true. Because an open category, an open VLOS flight, flying over a controlled portion of airspace, or flying over Colosseum, for instance, do need authorization, and collecting authorization for all the interested parties might be a nightmare. And this is just for a VLOS operation. Can you imagine what happens when you want to extend the flight length, the flight path across maybe 10th or 100 of kilometers or across the country? Many institutions will be interested about that flight. Much more complex will be the authoritative process. This is something that we need to keep into account. And we think that the NSP and the flight, as a the daughter company of the air navigation service provider in Italy, has the right recognition at the institutional level to interface with all these institutions and provide support for authoritative process to the drone operators. So I think this is a very important role that we should consider. The U-Space Service Manager, we call the central entity, would also allow downstream USSP to develop and build up their own business opportunities. So, in other terms, there is, you might know, there is a quite a significant struggle in Europe currently between a centralized vision and a decentralized vision. What is right, what is wrong, what is better, what is worse. We cannot say, probably there is no one solution fitting all. We might say that probably the right approach would be to make a service per service analysis, deciding which service is better to be centralized, at least in some countries, and what services can be let outside on the open market. But the message I want to give is pay attention. The U-Space service portfolio is just a small part of a full value chain, which is extremely big. So please don't try to say all the U-Space service all the U-Space services need to be liberalized, because otherwise we are creating a non-competitive market or a monopolistic situation. There are a set of services that should probably better be centralized for a number of reasons, as Fabrizio well explained. This does not represent a blocking situation for the rest of the potential U-Space service players, because the value chain is big, and for the time being there is no market, because drones are not flying, whether we like it or not, and this is an issue. And what we are trying to do in Italy through the flight is actually enabling the market to start. And when the market will start, when drones will be able to fly in a routinely way in BVLOS or autonomous, so that enterprises and Amazon and Google and whoever will be able to deliver parcels with drones, and enterprise will be able to make inspection management, then there will be a full market where all U-Space service provider providing a full set of different services, from asset management to supplement data services, infrastructure, and so on and so forth, will have a market to sell their services to. So, in conclusion, our institution believes in a century approach, at least for a small set of services that we think should be regulated and should be set on a centric basis to allow the market to exploit in a safe manner. D-Flight is actually an aggregator of different U-Space service provider potentially coming into the market in the next future. Is not at all a barrier for them to enter this market. Actually, we think D-Flight, and thanks to ENAC and INAV to believe in that at the very beginning by signing this agreement, is the catalyst for the market and one of the main enablers for the market of drone operation to be exploited as soon as possible. Thank you.
Thank you, Fabrizio and Cristiano. Very interesting presentation. I saw some nods on the audience. I think we have a lot to discuss. Let me welcome our next speaker, Daniel Garcia Monteavaro Vizcaino, Head of Drone Business Development Department for Air Spain. Daniel, the floor is yours.
Okay, good morning to everyone. I'm giving this presentation on behalf of ENAIRE as a Spanish NSP, and also as the DGIC, the National CAA. The presentation will be oriented especially to European framework, and the main points the presentation will be is answering to the request for information, okay? The UTM service supplier definition, first of all, different types of architecture that we yesterday already seen, certification requirements, and the standards, what sources can apply to UTM framework. So, what is a UTM service supplier? Well, we know responsible for the provision of services to the US operator, to give extra value to its customers, to differentiate from different UTM service suppliers, to compete in a fair open market, and to be certified for a certain type of operation and or a specific airspace. So if you take a look at the diagram, the UTM service provider provides all the information that is needed by the mission, for instance, from weather forecasts, and to traffic updates and aeronautical information. So now, let me illustrate the difference, the operation between the classic ANSP operation and the new UTM operation. Well, we all know that it provides services to drone operators. The drone operator is a different profile, very different profile, not from the classic pilot, the classic manned aviation. It's a mission-specific oriented, scalable operation from few drones to a large number of drones. And how is the mission? The mission can be very detailed, diverse, and very dynamic. And if we take a look to the ANSP, well, we all know the service provided in a broader manner, large scale, is rigid, and especially slow for new technical implementations. So these previous considerations, and according to different studies and demonstrations here in Europe, lead to the endorsement of a layered and federated system with three main actors, as it is shown in this central graphic. The drone operator represents the diversity of mission and flight requirements. The UTM service suppliers that gives the response to the needs of the missions and operators. And the controversial thing, the orchestrator, the central DTM, ecosystem manager, inter-USB platform. So what we know is that we need a coordinator actor, right? That is something that we more or less, it's clear. So this leads to different architecture, right? We are going to start for the centralized concept. Okay, this chart is based on corrups or CONOPS from USpace. And we can see here one central platform. All services performed by the central entity. The ANSPN authorities are connected to this central DTM or central platform, and the open market is very limited. Now, totally opposite, as we saw yesterday at least twice, is this graphic based on the FAA architecture, what we have these FIMS, okay, this FIMS figure, the Flight Information Managed Service, but the critical services in this case are performed by the UTM service suppliers. How they coordinate? They coordinate with the inter-USB platform. It's not in hands of the Flight Information Managed System. And there is a very limited interaction between the common information provider, that this is known in Europe, or the FIMS, and the drone operator. So in the balance, that's where we have a thing that it's one of the best solutions. It's what we call a federated architecture, where there is a neutral central platform with critical services and as a single point of truth. And the USpace service providers, and I say USpace because it's in this case in the European framework, it connects to the ecosystem manager. And they are in charge of non-critical services. It's an open market, and there is a fair access to the market for newcomers, for the new USpace service provider that connect to this ecosystem manager. As you can see, the ATM system is connected through the ecosystem manager, and privileged users like military or local authorities, law enforcement, are connected to this ecosystem manager too. Eventually, sorry, one moment. Well, so this is the architecture we adopted in Domus project in Cesar. And eventually, can be a first deployment. Eventually, there can be more interaction between USPs, okay, and even the drones by B2B, vehicle-to-vehicle information. But the protocols and the technology has to be more reliable. The benefits of this federated architecture is that the ecosystem has the more core critical functionalities, interface with the manned ATM, as I said, a single point of truth. Provides the central legal entity bearing responsibilities and liabilities, that is very important, guarantees neutrality and hosting critical USpace services by the ecosystem manager, and the USPs are guaranteed equal and fair access. Requires less effort for the certification of USPs, easier deployment for advanced USpace services, and the military or law enforcement mission will remain unknown to other users because all this information will be in the ecosystem manager platform. About certification, in the framework of European, we think that would be a stricter certification for the orchestrator or the ecosystem manager, and would be less restrictive for the USpace service providers. The requirements would be focused on compliance with communication, navigation, and surveillance, interface standards, and to be defined performance criteria. The service level agreements are highly relevant, depending on the mission. It's not the same in urban environment or in rural environment. What are the difficulties found in the European framework for the regulation? Well, all the USpace service provider has to be, the certificate has to be mutually recognized in all EU member states. It has to be a harmonized implementation plan and a common framework and criteria goals. This is, well, a simplistic chart of flow, the certification actors as from Europe to, for example, to Spain government. But the most important thing of this flow chart is the new player that we have here comparing to the ATM world. And is in the bottom left, the local authorities. Local authorities, local administrations. These are new players that have to get into play in the UTM system. Certification key points. There has to be a competent authority designated at national level to demonstrate that the Airspace service supplier have systems and equipments that guarantee the UTM performance level, financial stability and solvency, comply with interoperability, liability insurance, and of course, any requirements depending on the final UTM framework. So let's talk now about the standards. What is the current situation? We know there are plenty of groups, EUROCAE, STM, ISO Eurocontrol, SILE, etc. And we have coordination problems. For example, for the foundations, USpace services like the e-identification, we have more or less two standards, the ACTM, and for example, the EUROCAE work group 105, the subgroup 32, that is addressing the same standard. So it's very important to rely on industry administration through coordination groups like USEG, ACD STAN, or as we listened yesterday, the Truth Framework from ICAO. This is another example. For future standards, Florian introduced this morning, it could be an important source, the feedback from all research and demonstrators projects that has been funded by the European Commission. INERE has participated, or is participating, in DOMUS and SafeDrone. The initial study report has already been delivered with conclusions and the recommendations and standards that we want to put in the outcome will finally in the next month. In the right, you have a graphical summary of the DOMUS project with the upper left, the ATM integration, a U3 service. In the bottom left, a tactical deconfliction situation. And in the bottom right, for example, and the manned aviation integrated into Airspace. You can see the trials of DOMUS in an AIRE channel in YouTube. They are completely uploaded. And the Cesare use consolidated results of all these projects that we insist that we think that are a very important outcome will be presented, for example, in the World ATM in Madrid in March 2020. So I will be happy to see you everyone in my country. And we think that these results will be very, very important to pave the way for the new regulation and the initial deployment of Airspace services. Thank you.
Transformation with the Digital Transformation Architect from Swiss Federal Office of Civil Aviation. Please, the floor is yours.
All right. Thank you very much, dear colleagues, dear friends, industry members. So I will focus on a smaller question maybe than my colleagues, which is simply how do we, as an authority, approve USP, Airspace Service Providers? And I will argue that this is hard work, but it is not a hard problem. And as authorities, we need to be in a position to take this as a product development and use the same best practices as you see in the industry in uncertain environments. So what does that mean? First of all, what's easy for us as authorities is that we're guided by a set of principles that is not up to us to decide. This is what our politicians give us and we must comply with. So for instance, we know that Airspace must be safe, efficient, secure, and green. By that, I also include the public acceptance. We need to make sure that there's not too much noise, no impact on the environment, and so forth, right? Open, flexible, and competitive, at least in Switzerland, this is a given. So everything that can be left to the open market must be left to the open market. And finally, it is also clear that we want, and this is full consensus, no need to go further, international harmonization. So this is easy, right? Within that framework, we don't have to invent anything as an authority. So how do we then go about testing our assumptions? There are many questions that have been already asked by my colleagues. Centralized versus decentralized. Networked or on board? So what can the drone do? What can be done at the edge of the network? What can be done at the ground control station and, or in your smartphone? All of that are questions that we're still trying to figure out. And how do we oversee? Is it a manual oversight? Is it an automated oversight where we have, in computer science, you would call that DevOps, a DevOps approach, meaning that you have a system that automatically checks what happens and you don't have to do anything manually? All of those questions are hard to answer, we agree. So why would we, as an authority, try to invent a solution today? The right answer is we must have a process that allows us to iterate and understand progressively what's happening. So that kind of flexibility is what we're aiming at. It's not the final answer that we have. We all agree we don't have it. So we must focus on the process. So again, now we're alone as an authority. It's not going to work. So what have we done? We have a group called SUSI, the Swiss Airspace Implementation. This group has been done in partnership with our ANSP, SkyGuide. Florent Béron is here. Florent, if you can wave so people know that if they have questions for you later on, they can go back to you. And about 20 and soon to be 30 industry partners. And this dynamic is what will allow us to understand. So first of all, when we're so many people, we need to make sure that we understand each other. So if you want to be part of SUSI, you must agree with our CONOPS. The CONOPS is the Swiss FOCA vision of USpace. It will change. We have a V1. There will soon be a V2. And that V2 will be very different thanks to the work we have done with SUSI. But if you don't agree with our CONOPS at this stage, obviously it's hard for you to be part of it. So that's the first step. We have our partners, we have a common vision, we have a way of implementing it, and then, we start doing it. So here is a small list, and it's probably not up to date, of the members we have in SUSI. Again, if you have 20 times the same kind of company, obviously it's not going to bring you a lot. So you need to have a variety. But again, it's a very vibrant ecosystem that we have, and therefore, I think most countries will be able to get good participation. You might know some of those companies or not. They are all very interesting and do a lot of different things. So, what have we done in a year since we launched SUSI? There are two things that have been tested. The first one is the themes. And again, we might be interested in saying, and the FIMS is doing all of this and all of that. I think what we learned once we launched the FIMS, thanks to SkyGuide, there has been a lot of feedback, and it's been very constructive. It's not been easy, right? It's not been like everybody agreed and it was great and we moved along. But that discussion, because it was the question of how do we make it operational, how can we use it, we made tremendous progress. And now, early next year, we'll be able to launch the FIMS. It will be a small FIMS. We'll have traffic information. We'll have AIM. So you start small. But by starting small, you're able to deliver, and you're able to get the feedback, and you can grow. So this is already the first achievement that you cannot do if you work alone. The second item that we delivered is remote ID. So we have on our website a full report on remote ID. If you want to read it, you can simply go on BAZL, B-A-Z-L, remote ID, search that on Google, and you will find it. It's fairly easy to find. And here we learned that we can use a standard, here it's the ASTM standard, to meet our goals. What's interesting in that ASTM standard is that sure, there's a broadcast solution to remote ID. We have a few concerns about it, and we're not hiding it, so we're discussing that also with the industry. And there's the network solution. That network solution is based on the DSS, which has an implementation, open source, called Inter-USS. So you have the standard, you have its implementation, and we were able to see it working with different industry partners that were able to use it, and we could see there was no hiding. It was not an ID, it was not plans or promises, it was an actual implementation. Based on that, we're not able to go to the next step, the iteration, to say, okay, we're going to go to a voluntary approval process where we will require USPs to implement the ASTM standard, and then do it for drone operators that want to not have easier access to us, because we'll still give access to everybody the same. But I think that many drone operators, and I'm sure we all share that vision here, want to be good citizens. They're always happy if you give them the opportunity to be safer, to be more transparent, they jump on it. This is my experience. And of course, you have some edge cases, but it's not the case. So again, next year we'll be able, thanks to this experience, to move and have this voluntary remote ID in place. And then we can move. We are already looking into flight plan sharing, how we're going to do that. We're also going to use a DSS to share information, data exchange hub, and so on and so forth. So you don't have to invent. I don't think you need to have that vision, but then when it's time to approve, we can simply go and test and do. So this is my message. It's fairly simple. It's only when you do that you learn. And for authorities, I think we need to get in the habits of always testing, iterating fast. So this is my message. Thank you.
So you already have 4 questions here from the floor. One from Steve, and please volunteer if you want to answer. What safety steps being made to ensure law enforcement and airport authorities can quickly neutralize a rogue drone or a drone that is on site for malicious intentions? Want to take? Okay.
Okay. It's an interesting discussion. I think counter-UAS is out of scope for this discussion, I have to say. However, if you look at law enforcement, so we'll have a video, you can also look at it on remote ID. It is a game changer for local police because they know exactly who they authorized, and then they're able, from their office, to know who is flying. So of course, when they get a phone call, it's much easier for them to know if they must act or not. Then, unfortunately, there's no unique solution to take down a drone, from the eagles to nets and everything. We see many, many different aspects. There I have to say that I would consider this a little bit out of scope for this panel.
Is it okay? Yeah. I think Airspace is basically concentrating on the cooperative drones, on the principle of cooperation. So, by definition, counter drones services or activity or concepts or solutions are somehow not directly inside the scope of Airspace. On the other hand, I think there is a strong complementarity. As for today, whatever drone you see in the sky, you might not know whether it is a menace or it's a drone which has the full right to be there. Once the Airspace will be there, it will provide to any actor on ground the information whether that drone is recognized as a drone having the right to be there, and drones that not have the right to be there. It doesn't mean automatically that the last one are really renegades or menace, but at least you have an indication. And so, and this situation will be complex, more complex and complex when we will move through the future, because several airports will use drones for their own operations. We will use drones for tuning nav aids, for instance, instead of aircraft or helicopters. So there will be more and more drones flying within ATZ even. So if the question is how you protect the airport from drones, well, we do not have the answer right now. We do not even know, because this is an ongoing discussion whether is the NSP or the airport manager or whoever that has first of all the obligation to perform the detection, and then who is the one that has to perform the resolution of the detection, because these are two different things. Again, for sure, this is no one of the two are in charge of USpace for the time being, but certainly USpace will collaborate with those operators in terms of providing them the information on who are the good drones.
We have more questions now. Thanks. I have a lot of questions coming. One question for DFlight and FOCA. How do both relate to the current EU requirements that EASA is requiring a remote ID to be broadcast directly from the drone and not through network?
Thank you for the question. Of course, the EU regulation provide for what we call local remote identification service. I think this service, the purpose of this service is to respond primarily to the need for security. So that's the business case for local remote identification. The business case for local remote identification is certainly not for increasing the safety of the situation awareness of a portion of airspace. For that purpose, we have what we call tracking, positioning, conspicuocy, and so what we think is networking electronic identification, together with the positioning of drone to some kind of federation or central entity able to build this situation awareness picture. For sure, the technologies might be somehow the same or complementary. Of course, if we think local electronic identification system, I was been shown for a unified solution for some hundred of meters of range for this kind of transponder, which should be on board on every drone. If you want to create a situational awareness picture of a whole country, you might need to deploy how many thousands of antennas for doing that. So for that purpose, you would probably need a networking solution. I know the discussion about what is the best solution is still ongoing. There are probably a number of hypotheses. No one fit for all, again, because you might go for LTE or in the next generation 5G, but for sure you might not have the complete coverage all over the country, especially when you move to a sparsely populated area. You might not have LTE or 5G coverage, so you might need a multi-purpose, multi-layer transponder for guaranteeing the seamless communication between the drone and whoever is in charge to collect all drone tracks within a certain portion of airspace.
Yeah, here the situation is again fairly simple. The ATM standard provides both paths. So you have Bluetooth or Wi-Fi as your broadcast solution. There's a little mismatch in the industry because very few drones have Bluetooth already, where all your phones have Bluetooth ready. Wi-Fi aware, which is the solution for Wi-Fi, is the opposite. So you have many drones able to do that, very few phones able to get it. So that's what we need to solve, but it's there. It's a matter of deciding, I would say. And then the network solution was tested from the ground control station to your mobile phone if you want to have network. So that works pretty well everywhere you have coverage. In that sense, both solutions are complementary. Some countries like Switzerland, where we have a lot of coverage because it's a small country, network is a great solution for many use cases. Larger countries obviously have different challenges, but both solutions will have to work together, and they already do, so that's fine.
I have time for one more. This is related to converting QNH to local pressure to the same as QFE. Will the barometric accuracy be sufficient to provide lower separation standard 1,000 or 500 for manned compared to 200 for unmanned?
Can you repeat the question, please?
I'll go for the short part of the question. Will the barometric accuracy be sufficient to provide lower separation standards, 1,000 or 500 feet compared to the 200 for the human aircraft?
In case of Domus, what we did was to use the GPS altitude, okay, and with the ADS-B in the manned aviation. So we comparing the ADS-B and we did it locally. Okay, the airplane was with the ADS-B that was from barometric altitude and the GPS in our tested area, in our test area. The performance was quite good. Well, that were the results. What we think maybe in the future, the altitude reference, I don't know if it's possible or not, should be with two different digits in the same place to have the GPS and the barometric altitude at the same time. I don't know if that would be possible or not.
And then please, the person who made the question, if you want to address direct the panel during the coffee break, please. I'm not going to dare to pronounce your name because it's very difficult. Yes?
Just for information, the person that asked the question, I'd encourage you to take a look at the video stream from the session next door, because there was a couple of sessions that addressed exactly that issue of barometric versus GPS altitude. So the nice thing is it's all recorded, so you'll be able to check that. I think it was the second and third one this morning. So thank you, Carlos.
Let's conclude our morning session, and thank you for the contribution, the question. They keep coming. Please keep making your questions. As a reminder for those here in Montreal and those in line, we will begin the second session at 11 o'clock. And the coffee break we are going to have now is sponsored by the Boeing company. Thank you.